Hello, welcome to my channel CNCERT Science and Math Concept. Here we are doing the question from the topic electric charge and field. The question is, obtain the formula for the electric field due to a long thin wire of uniform linear charge density lambda without using Gauss's law. Means we do not have to use Gauss law, and the wire is long. Long means it has infinite length. So first of all, we consider that this is a long wire having charge on it. Linear charge density means charge per unit length. Now on this wire, I consider a perpendicular line at this point. Say this point is O, and at a distance y from wire, at this point P, we are going to find out the electric field due to this long charged wire. Now suppose there is a small portion of the wire at this point of length dx having charge dq. Then dq by dx, charge per unit length, is linear charge density, that is lambda. Therefore dq is equals to lambda dx. Now from this charge we join the point P and say the distance O to this point I consider that A point. O to point A is equals to x, and say this angle is theta. Then the electric field due to this small charge dq will be along the line away from the charge, that is dE, in this direction. Now this dE will be having two components. One will be along y-axis, that is dEy, and another will be along x-axis, which is going in the opposite direction of positive x-axis. So this is dEx. Now what will, and this is distance x, OA is x, OP is y. Therefore the distance r, which we consider as r, will be equals to under root x square plus y square. Now therefore the electric field dE due to charge dq will be equals to 1 upon 4 pi epsilon 0 dq by r square, which can be written as 1 upon 4 pi epsilon 0 dq is lambda dx upon r is under root x square plus y square. Therefore r square will be equals to x square plus y square. This is relation number 1. Now there will be two components that already we have shown in the diagram. So now dEx will be equals to, if this is angle theta, so vertically opposite angle is also theta, then dEx will be equals to minus dE sin theta, and dEy will be equals to dE cos theta. Now as we see from the diagram, if suppose the wire is having a finite length and O is the center, then due to right side of the wire carrying charge, your x component is minus dE sin theta. Similarly from the left hand side, it will be towards positive side, that is plus dE sin theta. Whether the wire is finite or whether the wire is infinite, the x component will be equal and opposite. Therefore the x component will not give any effect on the net electric field. Hence we can say that net electric field dE will be equals to dE cos theta, or we can say E is equals to component along y-axis, that is equals to integration dEy. Now this dEy is from right side of the wire. If we want for complete wire, this is for right side of the wire, I am taking E dash. Therefore total electric field will be right side plus left side, that is 2E dash that is equals to 2 integral dEy, which can be written as 2 dEy. dEy is dE cos theta, so integration dE is 1 upon 4 pi epsilon 0 lambda dx upon x square plus y square into cos theta. Now, when we are taking this integration, we should put the limits. Now, initially, when we go from 2 dEy, the x is from, now we have considered O as the center point, and we have taken 2 times because from right side and left side. So, we are going from 0 to infinity. So, it is 0 to x is equals to infinity. Otherwise, if you don't take 2, then you will have to take x is equals to minus infinity to plus infinity. So now we have to change the limits when angle is being taken. So here it is x is equals to 0 to x is equals to infinity. Now from the diagram again we can say that from the diagram in triangle POA, x tan theta. What is tan theta? Tan theta is equals to x upon y, or x is equals to y tan theta. So now we put this value in our equation. So we are having x is equals to y tan theta, but we want dx, so we differentiate it. So dx is equals to y's differentiation of tan theta is secant square theta d theta. Now therefore E is equals to 2 is constant into 1 upon 4 pi epsilon 0 is also constant, lambda is also constant, integration. Instead of dx, now it will be y secant square theta d theta cos theta divided by x is equals to y tan theta, so I can say y square tan square theta plus y square. Now we have to change the limits. Now for limits, x is equals to y tan theta. Lower limit is 0 and it will be y tan theta. Tan theta will be 0 when theta is equals to 0. So here it is, lower limit becomes 0 degree. Now it will become infinite, y tan theta. It will be infinite only when theta is equals to pi by 2. So the limit is from 0 to pi by 2. Now further we solve it. This is lambda. I cut 2 and 4, that is 2 pi epsilon 0. This is lambda upon 2 pi epsilon 0 integration from 0 to pi by 2 y secant square theta cos theta d theta upon, I take y square common, it becomes tan square theta plus 1, and tan square theta plus 1 is secant square theta, so E is equals to lambda upon 2 pi epsilon 0. For this requirement our y is also constant, so 1 gets cancelled, so I also take y outside into 1 upon y integration secant square theta into cos theta into d theta divide by secant square theta. Limits are from 0 to pi by 2. Secant square theta also gets cancelled. Therefore, E is equals to lambda upon 2 pi epsilon 0 into 1 upon y. Integration of cos theta is sin theta from 0 to pi by 2. Therefore, E is equals to lambda upon 2 pi epsilon 0 into 1 upon y sine pi by 2 minus sine 0. Sine pi by 2 is 1, sine 0 is 0, so 1 minus 0 is 1. Therefore, E is equals to lambda upon 2 pi epsilon 0 y. So the result here we get the electric field due to long wire carrying charge is equals to linear charge density divided by 2 pi epsilon 0 y. That is all for this question. Keep watching my other videos for more challenging questions and do subscribe my channel.